Hi, we are back in our Python programming book, third edition by John Zelle, and I am still in chapter 11. This is the third section, trying to finish chapter 11. We are on page 399 if you have the book and would like to read as you listen. All right, so at the top of 399, it starts with some code. I'll start at the paragraph beneath that. Remember, the parameter dt tells the amount of time into the future to move the shot. The second task is to remove the dead shots. We can tell whether a shot is still alive by testing that its y position is above 0 and x is between -10 and 210. It's tempting to add an if statement that checks this and then simply deletes a dead shot from the list. Okay, so here's the code. If shot.getY, empty parentheses, less than 0, or shot.getX, empty parentheses, arrow, -10, or shot.getX, empty parentheses, greater than 210, colon, self.shots.remove, and then shot inside parentheses. But this is a bad idea and can lead to erratic behavior. The reason it is that the loop is iterating through self.shots, and modifying that list while looping through it can produce strange anomalies. A better approach is to use another list to keep track of which shots are still alive, and then change self.shots at the end of the method. Taking this approach, here is the code for update shots. Code. Def update shots with a capital S, open parentheses, self, comma, dt, end parentheses, colon, new line. Alive equals empty brackets. New line. For shot in self.shots, colon, new line, shot.update, dt inside of parentheses, new line, if shot.getY, empty parentheses, greater equals 0 and -10, left facing arrow, shot.getX, empty parentheses, less than 210, colon, new line, alive.append, shot inside parentheses, new line, else, colon, shot.undraw, new line, shot.undraw, empty parentheses, new line, self.shots equals alive. I'm sorry for the inconsistencies there. Notice how this code accumulates the list of shots that are still alive and then updates self.shots after the loop has completed. Also, I have added an else to undraw the dead shots. If we're going to be firing lots of shots, we probably don't want all the dead ones piling up at the bottom of the window. The last step is to add a line of code at the bottom that actually runs the application. Here's the code. If __name __ equals open quote __ main __ end quote colon new line projectile app empty parentheses .run empty parentheses. The animation is a lot of fun to play with. You'll want to grab the example program animation2.py from the supporting materials and give it a run. The exercises at the end of this chapter include ideas for some modifications. Before tackling those exercises, however, it is crucial that you have a solid grasp of what we've built so far. The key to understanding the final program is to keep in mind what each class does and how they all work together. Figure 11.3 depicts the main classes. I'll show you the figure from the book. Let me see if I can line it up to the camera. You see that illustration? What am I pointing at? There. There's the illustration that we are currently discussing. Hopefully you can follow along in your book and see the illustration. There are 4 squares and arrows pointing to them, and the label underneath says class diagram for the multi-shot animation. So there's 4 different sections: the launcher section, the graph win section, the shot tracker section, and the projectile app section. And continuing on, the boxes show the instance variables and methods of a class, and the arrows show how one class depends on another. The number at the end of an arrow is a count of the number of depend-on objects of the class pointed to. For example, a projectile app has an instance variable for a single graph win and for a single launcher, but it maintains a list of multiple shot trackers indicated by the count n. I used a dashed arrow from launcher to shot tracker because the launcher creates instances of shot tracker, but it does not store or manipulate a shot after creating it. That's the projectile app's job. A class diagram like this is the object-oriented analog to the structure charts that we used back in Chapter 9. It captures the overall structure of the final system without getting bogged down in all of the details of the code. In fact, this is only a partial diagram of our completed program. Did you notice that the dependencies for shot tracker were not included? I purposely left those out to focus on the main classes. I leave it as an exercise for you to complete the picture. Class diagrams are often useful for thinking about object-oriented programs, and you should get some practice drawing them. So I encourage you to go ahead and pause the video and fill that in, or we continue on with section 11.7, non-sequential collections. Python provides a number of built-in data types for collections. After lists, a collection type called a dictionary is probably the most widely used. While dictionaries are incredibly powerful, they are not as common in other languages as lists, otherwise known as arrays. The example programs in the rest of the book will not use dictionaries, so you can safely skip the rest of this section if you've learned all you want to learn about collections for the moment. Section 11.7.1, Dictionary Basics. Lists allow us to store and retrieve items from sequential collections. When we want to access an item in the collection, we look it up by index, its position in the collection. Many applications require a more flexible way to look up information. For example, we might want to retrieve information about students or employees based on their ID numbers. In programming terminology, this is a key-value pair. We access the value, the student information, associated with a particular key, an ID number. If you think a bit, you can come up with lots of other examples of useful key-value pairs. For example, we have names and phone numbers, usernames and passwords, zip codes and shipping costs, state names and capitals, sales items and quantity in stock, etc. A collection that allows us to look up information associated with arbitrary keys is called a mapping. Python dictionaries are mappings. Some other programming languages provide similar structures called hashes or associative arrays. A dictionary can be created in Python by listing key-value pairs inside curly braces. Here is a simple dictionary that stores some fictional usernames and passwords. We have arrow, 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 PASSWD, short for password, equals curly bracket, right? What do they call them? Curly braces. open curly brace, in quotes, Guido, colon, in quotes, super programmer, comma, in quotes, Turing, colon, in quotes, genius, comma, Bill, in quotes, colon, monopoly, in quotes, and then we need an end curly brace. Curly brace, this is new to me. All right, turning the page, notice that keys and values are joined with a colon. And commas are used to separate the pairs. Fair enough. The main use for a dictionary is to look up the value associated with a particular key. This is done through indexing notation. Here we go. Arrow, 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 password, open bracket, quote unquote, Guido, end bracket, new line, single quote, super programmer, end single quote, new line, arrow, 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 password, open bracket, Bill, in quotation marks, end bracket, new line, single quote, monopoly, single quote. In general, dictionary and key returns the object associated with that given key. Dictionaries are mutable. The value associated with a key can be changed through assignment. So mutable means changeable. Immutable means unchangeable. But here we have dictionaries are mutable. Here we have some code. Arrow, 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 password, open bracket, open quote, Bill, close quote, close bracket, equals, quote unquote, blue screen. New line, arrow, 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 password. We have curly, what did they call it? Curly brace, curly bracket, I forget. Curly brace, open curly brace. Single quote, Turing, single quote, colon, single quote, genius, single quote, comma, single quote, Bill, single quote, colon, single quote, blue screen, single quote, comma, backslash, single quote, Guido, single quote, colon, single quote, super programmer, single quote, end curly brace. In this example, you can see that the value associated with Bill has changed to blue screen. Also, notice that the dictionary prints out in a different order from how it was originally created. This is not a mistake. Mappings are inherently unordered. Internally, Python stores dictionaries in a way that makes key lookups very efficient. When a dictionary is printed out, the order of keys will look essentially random. If you want to keep a collection of items in a certain order, you need a sequence, not a mapping. To summarize, dictionaries are mutable collections that implement a mapping from keys to values. Our password example showed a dictionary having strings as both keys and values. In general, keys can be any immutable type, and values can be any type at all, including programmer-defined classes. Python dictionaries are very efficient and can routinely store even hundreds of thousands of items. Section 11.7.2, Dictionary Operations. Like lists, Python dictionaries support a number of handy built-in operations. You've already seen how dictionaries can be defined by explicitly listing the key value pairs in curly braces. You can also extend a dictionary by adding new entries. Suppose a new user is added to our password system. We can expand the dictionary by assigning a password for the new username. Here we go. Arrow, arrow, arrow. Password, open bracket, single quote, new user, end single quote, end bracket, equals single quote, I'm a newbie, end single quote. New line, arrow, 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 password, curly brace, single quote, Turing, end single quote, colon, single quote, genius, and single quote, comma, single quote, bill, and single quote, colon, single quote, blue screen, single quote, comma, backslash, single quote, new user, and single quote, colon, single quote, I'm a newbie, and single quote, comma, and nope, comma, single quote, Guido, and single quote, colon, single quote, super programmer, end single quote, and curly brace. Right? Okay. In fact, a common method for building dictionaries is to start with an empty collection and add the key value pairs one at a time. Suppose that usernames and passwords were stored in a file called passwords, where each line of the file contains a username and password with a space between. We could easily create a password dictionary from the file. Here we go. Password equals empty curly braces, empty curly braces. New line, 4-line in open parentheses, single quote, password, single quote, comma, single quote, R, single quote, end parentheses, colon, new line, user, comma, pass, equals, line dot split, empty parentheses, new line, password, in brackets, user, equals, pass. New line, no, paragraph. To manipulate the contents of a dictionary, Python provides the following methods. And in the book, you can see a chart. So if you have your book open, there's a, no, not that side, this side. There's a chart here that shows method and meaning. Very useful to manipulate the contents of a dictionary. So these methods are mostly self-explanatory. For illustration, here is an interactive session using our password dictionary. Turn the page and you will see we've got more coding. Arrow, 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 list, open parentheses, password.keys, empty parentheses, end parentheses, new line, open bracket, single quote, Turing, single quote, comma, single quote, bill, single quote, comma, single quote, new user, single quote, comma, single quote, Guido, single quote, end bracket. New line, arrow, 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 list, open parentheses, password.values, empty parentheses, end parentheses, new line, open bracket, single quote, genius, single quote, comma, single quote, blue screen, single quote, comma, single quote, I'm a newbie, single quote, comma, single quote, super programmer, single quote, end bracket, new line, arrow, 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 list, open parentheses, password.items, empty parentheses, end parentheses, new line, bracket, open parentheses, single quote, Turing, single quote, comma, single quote, genius, single quote, end parentheses, comma, open parentheses, single quote, bill, single quote, comma, single quote, blue screen, single quote, parentheses, comma, backslash, new line, maybe not a new line, but we have parentheses, open parentheses, single quote, new user, single quote, comma, single quote, I'm a newbie, single quote, end parentheses, comma, open parentheses, single quote, Guido, single quote, comma, single quote, super programmer, end single quote, end parentheses, end bracket. New line, arrow, 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 quote, bill, end quote, in, password. New line, capital T for true. New line, arrow, 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 single quote, Fred, single quote, in, password. New line, capital F, false. New line, arrow, 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 password dot get, open parentheses, single quote, bill, single quote, comma, single quote, unknown, single quote, end parentheses, new line, single quote, blue screen, single quote, new line, arrow, 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 password dot get, open parentheses, single quote, John, single quote, comma, single quote, unknown, single quote, parentheses, new line, single quote, unknown, single quote, new line, arrow, 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 password dot clear, empty parentheses, new line, arrow, 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 password, new line, empty, curly braces. Whew. It's so much more difficult when you have to read every character than when you have to read every word. That's what's taking this chapter so long. Section 11.7.3, we are making progress. Example program, word frequency. Let's write a program that analyzes text documents and counts how many times each word appears in that document. That sounds like tedious work, not fun. So this kind of analysis is sometimes used as a crude measure of the style similarity between two documents and is also used by automatic indexing and archiving programs, such as internet search engines. At the highest level, this is just a multi-accumulator problem. We need a count for each word that appears in the document. We can use a loop that iterates through each word in the document and adds 1 to the appropriate count. The only catch is that we will need hundreds or thousands of accumulators, one for each unique word in the document. This is where a Python dictionary comes in handy. We will use a dictionary where the keys are strings that representing words in the document, and the values are ints that count how many times the word appears. Let's call our dictionary counts. To update the count for a particular word, W, we just need a line of code that looks something like this, : here's the code, counts, W inside brackets, equals counts, W in brackets, plus 1. This says to set the count associated with the word W to be 1 more than the current count for W. There is one small complication with using a dictionary here. The first time we encounter a word, it will not yet be in counts. Attempting to access a non-existent key produces a runtime key error. To guard against this, we need a decision in our algorithm. Here's the code. If W is already in counts, : add 1 to the count for W. Else, : set count for W to 1. This decision ensures that the first time a word is encountered, it will be entered into the dictionary with a count of 1. One way to implement this decision is to use the in operator. Here's the code. If W in counts, : new line, counts, W inside brackets, equals counts, W in brackets, plus 1. New line, else, : new line, counts, W in brackets, equals 1. A more elegant approach is to use the get method. Here it is. Counts, W in brackets, equals counts.get, open parentheses, W, comma, 0, end parentheses, plus 1. If W is not already in the dictionary, this get will return 0. And the result is that the entry for W is set to 1. The dictionary updating code will form the heart of our program. We just need to fill in all the parts around it. We will need to split our text document into a sequence of words. Before splitting, though, it is useful to convert all the text to lowercase. So occurrence of foo match foo with a capital F versus a lowercase f, and eliminate punctuation. So foo, comma, matches foo without a comma. Here's the code to do those 3 tasks. Fname equals input, open parentheses, open quote, file to analyze, : end parentheses, end quote, then end parentheses. New line, hashtag, read file as one long string. New line, text equals open parentheses, fname, comma, open quote, r, end quote, end parentheses, dot, read, empty parentheses. New line, hashtag, convert all letters to lowercase. New line, text equals text.lower, empty parentheses. New line, hashtag, replace each punctuation character with a space. New line, for CH in open single quote. No, it's not opening a quote. It's just listing. Maybe it is. Single quote, exclamation point, quotes, hashtag, $sign, %sign, ampersand, open parentheses, close parentheses, asterisks, plus, comma, minus, dot, / colon, semicolon, left arrow equals, right arrow, question mark. Is that the @ sign? Or is that a typo? We have open bracket, // end bracket, an up arrow, underscore, single quote. We have a curly brace, a line straight down, an end curly brace, a tilde, an apostrophe or a single quote, and a colon. New line, text equals text.replace, open parentheses, ch, comma, empty quotation marks, end parentheses. So that's going to replace all of the punctuation characters in that list with a space. New line, hashtag, split string at white space to form a list of words. Words equal text.split, open parentheses, close parentheses. Now we can easily loop through the words to build the counts dictionary. Counts equal empty set of curly braces. For W in words, colon, new line, counts, W inside brackets, equals counts.get, open parentheses, W, comma, 0, end parentheses, +1. Our last step is to print a report that summarizes the contents of counts. One approach might be to print out the list of words and their associated counts in alphabetical order. Here's how that could be done. Hashtag, get list of words that appear in document. New line, unique words equal list, open parentheses, counts.key, empty parentheses, end parentheses. New line, hashtag, put list of words in alphabetical order. Unique words.sort, open parentheses, close parentheses. New line, hashtag, print words and associated counts. New line, for W in unique words, colon, new line, print, open parentheses, W, comma, counts, W inside brackets, end parentheses. For a large document, however, this is unlikely to be useful. There will be far too many words, most of which only appear a few times. A more interesting analysis is to print out the counts for the N number most frequent words in the document. In order to do that, we will need to create a list that is sorted by counts, most counts to fewest counts, and then select the first N items in the list. We can start by getting a list of key value pairs using the items method for dictionaries. Code is items equals list, open parentheses, counts.items, empty parentheses, end parentheses. Here, items will be a list of tuples. For example, foo, 5, bar, 7, spam, 376, etc. If we simply sort this list, items.sort, Python will put them in a standard order. Unfortunately, when Python compares tuples, it orders them by components left to right. Since the first component of each pair is the word, items.sort will put the list in alphabetical order, which is not what we want. To sort our list of items according to frequency, we can use the key function trick again. This time our function will take a pair as a parameter and return the second item in the pair. Here's the code. Def by freq, I don't know how to say that, FREQ with capital F, and then pair inside parentheses, colon, new line, return pair, 1 inside brackets. Notice that tuples, like lists, are indexed starting at 0. So returning pair 1 inside brackets hands back the frequency part of the tuple. With this comparison function, it is now a simple matter to sort our sum items by frequency. Items.sort, open parentheses, key equals by freq, short for frequency, end parentheses. But we're not quite finished yet. When we have multiple words with the same frequency, it would be nice if those words appeared in the list in alphabetical order within their frequency group. That is, we want the list of pairs primarily sorted by frequency, but sorted by alphabetically within each level. How can we handle this double sortedness? Looking at the documentation for the sort method via help bracket.sort, excuse my yawn, you will see that this method performs a stable sort in place. As you can probably infer, being in place means that the method modifies the list that it is applied to rather than producing a new sorted version of the list. But the critical point for us here is the word stable. A sorting algorithm is stable if equivalent items that have equal keys, stay in the same relative position to each other in the resulting list as they were in the original. Since the Python sorting algorithm is stable, if all the words were in alphabetical order before sorting them by frequency, then words having the same frequency will still be in alphabetical order. To get the result we want, we just need to sort the list twice, first by words and then by frequency. Items.sort, empty parentheses, hashtag order pairs alphabetically. New line, items.sort, open parentheses, key equals by freq, comma, reverse equals capital T true, end parentheses, hashtag orders by frequency. I've added one last wrinkle here. Supplying the keyword parameter reverse and setting it to true tells Python to sort the list in reverse order. The resulting list will go from highest frequency to lowest. Now that our items are sorted in order from most to least frequent, we are ready to print a report of the n number of most frequent words. Here is a loop that does the trick. For I in range, n inside parentheses, colon, new line, word, comma, count equals items, I inside brackets, new line, print, open parentheses, open quote, open curly brace, 0, colon, left facing arrow 15, end curly brace, open curly brace 1, colon, right facing arrow 5, end curly brace, end quote, dot, format, open parentheses, word, comma, count, end parentheses. The loop index I is used to get the next pair from the list of items, and that item is unpacked into its word and count components. The word is then printed left justified in 15 spaces, followed by the count right justified in 5 spaces. That about does it. Okay, so let's read the footnote. An experienced Python programmer would probably write this loop body as a single line using the tuple unpacking operator. That looks like this. The curious should consult the Python documentation to learn more about this handy operator. So if you want to go into that footnote and try that out and figure out what that means logically, then please feel free to do so. All right, so that about does it. Here is the completed program, wordfreak.py. So here we go, reading the code. Def by freak, open parentheses, pair, end parentheses, colon. New line, return pair 1 in brackets. New line, def, main, open parentheses, close parentheses, colon. New line, print, open parentheses. Quote, this program analyzes word frequency in a file, end quote, end parentheses. New line, print, open parentheses, quote, and prints a report on the n most frequent words, period, backslash n, end quote, end parentheses. New line, hashtag, get the sequence of words from the file. New line, fname equals input, open parentheses, open quote, file to analyze, colon, end quote, end parentheses. New line, text equals open parentheses, fname, comma, single quote, r, single quote, end parentheses, dot read, empty parentheses. New line, text equals text dot lower, empty parentheses. New line, for ch in single quote, exclamation point, double quote, hashtag, $sign, percent sign, ampersand sign, open parentheses, close parentheses, asterisk, plus, comma, dash, period, forward slash, colon, semicolon, less than, equal to, greater than, question mark, at, open bracket, backslash, backslash, end bracket, arrow up, underscore, single quote, curly bracket, line, end curly bracket, tilde, single quote, colon, new line, text equals text dot replace, open quote, ch, comma, single quote, end parentheses, new line, words equal text dot split, open parentheses, close parentheses. New line, hashtag, construct a dictionary of word counts. Count equals empty curly braces. New line, for W in words, colon, new line, counts, W inside brackets equals counts dot get, open parentheses, W, comma, 0, end parentheses, +1. New line, hashtag, output analysis of n most frequent words. New line, n equals eval, open parentheses, input, open parentheses, open quote, output analysis of how many words, question mark, end quote, end parentheses, end parentheses. New line, items equal list, open parentheses, counts dot items, empty parentheses, end quote. No, not end quote, end parentheses. New line, items dot sort, empty parentheses. New line, items dot sort, open parentheses, key equals by freak, comma, reverse equals capital T true, end parentheses. New line, for I in range, n inside parentheses, colon, new line, word, comma, count equals items, I inside brackets, new line, print, open parentheses, single, double quote, curly brace, open curly brace, 0, colon, less than 15, end curly brace, open curly brace, 1, colon, greater than 5, end curly brace, quote, dot, format, open parentheses, word, comma, count, end parentheses, new line, if, underscore, underscore, name, underscore, underscore, equals, single quote, underscore, underscore, main, underscore, underscore, single quote, colon, main, empty parentheses. Page 409, if you're following in your book. Just for fun, here's the result of running this program to find the 20 most frequent words in a draft of the book that you are reading right now. This program analyzes word frequency in a file and prints a report on the n most frequent words. File to analyze, book.txt. Output analysis of how many words? 20. So the word the is appearing 6,428 times. And I will let you read down the list of unuseful information all the way to and, which appears 470 times. Moving on to chapter 11, section 11.8. And this is the chapter summary. So we're finally winding down. This chapter has discussed techniques for handling collections of related information. Here is a summary of some key ideas. 1. A list object is a mutable sequence of arbitrary objects. Items can be accessed by indexing and slicing. The items of a list can be changed by assignment. Next, Python lists are similar to arrays in other programming languages. Python lists are more flexible because their size can vary and they are heterogeneous. Python lists also support a number of useful methods. Next bullet point. One particularly important data processing operation is sorting. Python lists have a sort method that can be customized by supplying a suitable key function. This allows programs to sort lists of arbitrary objects. Classes, new bullet point, classes can use lists to maintain collections stored as instance variables. Oftentimes, using a list is more flexible than using separate instance variables. For example, a GUI application might use a list of buttons instead of an instance variable for each button. New bullet point, an entire program can be viewed as a collection of data and a set of operations, an object. This is a common approach to structuring GUI applications. That is just copy and paste, right? New bullet point. A Python dictionary implements an arbitrary mapping from keys into values. This is very useful for representing non-sequential collections. Section 11.9 is a series of exercises. Feel free to stop the video and quiz yourself over this information so that you can prove to yourself that you know this information from this chapter very well. Thank you for joining me for chapter 11. My apologies for making it stretch over 3 videos. I always think I have enough time to get it done and then time runs out. Thank you for sticking with me, and I will see you in the next one. Bye.